You think space is empty, a stage, a background, a cold distance between things. You imagine stars scattered through a kind of cosmic silence, and you imagine that if someone looked deeply enough, carefully enough, honestly enough, they would simply find more of what was already there, more stars, more dust, more darkness. That is the picture you carry, and it feels reasonable, but it depends on a very dangerous assumption. You assume that looking deeper means seeing more clearly. You assume that reality becomes more stable when you examine it closely. You assume that distance makes things simpler. It does not, because the deeper physics looks into space, the less space behaves like a place. It stops feeling like emptiness, it stops feeling passive, it stops feeling like nothing. And the uncomfortable part is not that space contains strange things. The uncomfortable part is that space itself may be the strange thing. Not the objects in it, not the galaxies, not the explosions, the stage itself. You call it empty because your mind needs it to be empty. It needs a container, a backdrop, something that just sits there and allows the universe to happen. But what if that picture is childish? What if the vacuum is not absence, but activity? What if the silence is not silence? What if the deeper you look, the more the universe removes the very idea of nothing? Feynman understood something most people never let themselves feel. When you look hard enough, reality does not become more familiar, it becomes less negotiable. And space, what you call space, may be the first thing your intuition gets completely wrong. The illusion of empty space. You've never actually seen empty space. That sounds trivial at first, almost obvious. Of course you haven't. There's always something in the way. Air, dust, light itself. But that's not the real issue. The real issue is that even when you try to imagine emptiness, you don't remove everything. You can't. You picture a vast darkness, a kind of silent, infinite void. No stars, no planets, just black. But look closely at that image in your mind. It still has structure. It still has distance. It still has depth. It still has a place for things to exist, even if those things aren't there. You haven't imagined nothing. You've imagined an empty container. And that distinction matters more than it seems, because physics does not allow you to assume the container. It questions it. The idea of empty space is comfortable because it gives everything else somewhere to go. It separates objects. It keeps them from collapsing into one another. It provides order. But the comfort comes from experience, not from truth. You grew up in a world where space behaves predictably. You throw something, it travels through air. You look up, and there is distance between stars. Everything appears to sit inside a stable, silent background. So your brain builds a rule. Space is nothing, and nothing does nothing. It just sits there, passive, reliable, invisible. But that rule was never tested at the level where physics actually operates, because when physicists like Feynman began to look deeper, not just at objects, but at the space between them, they weren't trying to find more stuff. They were questioning whether the emptiness itself made sense, and slowly something uncomfortable started to happen. The concept of nothing stopped behaving like nothing. Not in a dramatic way, not at first. There was no explosion, no obvious contradiction, just small inconsistencies, subtle failures in expectation, places where equations refused to accept emptiness as a valid answer, places where nothing seemed to require properties, and that should bother you, because if empty space needs properties, then it isn't empty, and if it isn't empty, then your mental picture, this vast quiet void, is not just incomplete, it's wrong. Not slightly wrong, fundamentally wrong. You are not imagining absence. You are imagining a simplified version of something far more active, far more structured, and far less intuitive than your mind is willing to accept. And the deeper you go, the less your idea of emptiness survives. Not because we find things inside it, but because the idea of inside begins to break down, when nothing starts doing something. Let's take your idea of empty space seriously. Strip everything away. No particles, no radiation, no temperature, no motion, a perfect vacuum. If your intuition is correct, then this should be the most uneventful thing imaginable. No activity, no change, no behavior, nothing should happen. But this is exactly where physics refuses to cooperate. Because when you try to describe this perfect emptiness using the rules that actually govern reality, the equations don't settle into silence. They fluctuate. Even when you remove everything you can possibly remove, the system does not become still. It vibrates, not metaphorically, not as a poetic description. Mathematically, there is an irreducible restlessness built into what you thought was nothing. And this is where your intuition starts to fail in a very precise way. You expect that if there is no energy, nothing can happen. But quantum physics does not allow energy to be exactly zero. Not perfectly, not indefinitely. There is always a minimum level of activity, a baseline that cannot be removed. And that means even empty space carries energy, not borrowed from somewhere else, not temporarily introduced. It is simply there, built into the structure of the vacuum itself. Now your mind will try to reinterpret this in a safe way. You might think, fine, maybe space isn't perfectly empty, but it's still mostly empty. Close enough. But that instinct misses the point, because this activity is not happening in space. It is the behavior of space. The vacuum is not a passive stage where things occasionally appear. It is a system that cannot remain completely quiet. At incredibly small scales, far beyond what you can see or measure directly, this nothingness is constantly shifting. Pairs of particles seem to appear and disappear. Not because something is creating them in the usual sense, but because the vacuum itself cannot maintain perfect stillness. It is unstable in a very specific, lawful way. And that creates a problem, because your original definition of nothing depended on stability. Nothing should not change, nothing should not fluctuate, nothing should not produce effects. But now you are faced with a version of nothing that does all of these things, quietly, constantly, inevitably. So you are forced into an uncomfortable position. Either you keep your definition of nothing and reject what physics is telling you, or you accept the physics and admit that what you called nothing was never nothing at all. Feynman leaned into this discomfort. He did not try to repair the intuition, he abandoned it. Because once you accept that even the vacuum is active, the question is no longer what exists in space. The question becomes, what is space if it behaves like this? And that question does not lead to clearer answers. It leads to deeper instability. The failure of the background. You still want space to be a stage. Even now, even after accepting that it isn't completely empty, you're holding on to a quieter version of the same idea. Fine, you think, maybe space has some activity, some background noise, but it's still just the place where things happen. The events are real, the particles are real, the forces are real. And space is just where all of that unfolds. That belief feels safe, it keeps the structure intact, it preserves a separation between the actors and the stage. But physics does not preserve that separation. It erases it, because the more closely you examine what you call things, the harder it becomes to separate them from the space they occupy. Take a particle. You imagine it as a tiny object, a point, something with a definite location, sitting in space. But the picture doesn't survive contact with deeper physics. Particles are not little balls moving through a void. They are excitations of fields, and those fields are not placed inside space. They are spread throughout it, which means you can't isolate the object from the background anymore, because the object is a pattern in the background, a localized ripple in something that is already everywhere. So now your clean separation begins to dissolve. You no longer have something sitting in nothing. You have structure emerging from a continuous system, and that system, what you used to call empty space, is doing more than just holding things. It is participating, actively. The behavior of particles depends on the properties of the space they inhabit. Change the structure of space, and the behavior of everything inside it changes with it. This is not a minor detail. It means space is not neutral, it has rules, it has constraints. It has a kind of architecture, and the architecture shapes reality. So the idea of a passive background begins to collapse, because a true background should not influence the outcome. It should not interfere. It should not define what is possible. But space does all of those things. It determines how fields behave. It determines how forces propagate. It even determines what kinds of particles can exist. So ask yourself, if something controls the rules, enforces structure, and actively shapes outcomes, is it still just a background, or is it part of the system itself? Feynman understood that you cannot keep pretending there is a stage separate from the play, because the stage is woven into the script. And once you accept that, something deeper starts to unravel. Because if space is not just where things happen, then what you thought of as where may not even be a meaningful question anymore. When observation becomes invasive, you still believe that looking reveals. That observation is passive, that you can step back, measure carefully, and uncover what is already there. It feels obvious. You don't change a mountain by looking at it. You don't disturb a planet by observing its orbit. So you assume the same must be true for space itself. That assumption does not survive. Because at the level where Feynman was working, observation is not a neutral act. It is an interaction. And interaction means disturbance. To see something, you need to exchange energy with it. You need a signal, light, particles, some form of contact, and that contact is not gentle, it changes the system. Now, your intuition tries to minimize this. You imagine using a softer probe, a weaker signal, something delicate enough to reveal without affecting, but physics closes that loophole. There is a limit to how gentle observation can be. If you try to reduce the disturbance, you also reduce the information. And beyond a certain point, the system refuses to give you both precision and passivity at the same time. You are forced to choose clarity or non-interference, not both. So the idea of just looking begins to break down, because there is no such thing. Every measurement is a negotiation with reality, and the deeper you go, the more invasive that negotiation becomes. When physicists probe what you call empty space, they are not simply uncovering hidden details. They are forcing the system to respond. They are creating conditions under which the vacuum reveals behavior. But that behavior is inseparable from the act of probing itself. This is where your mental model starts to slip again. You want to believe there is a true state of space, something definite, something that exists independently of observation, but the evidence does not support that comfort. What you can observe depends on how you observe it, not in a vague philosophical sense, in a strict, measurable, unavoidable way. Change the method, and you change the outcome. So now you are no longer dealing with a stable background that patiently reveals its structure. You are dealing with a system that resists being pinned down. A system where the act of asking a question alters the answer. And that leads to a deeper problem. Because if observation changes what is observed, then what does it mean to say what space really is? Feynman did not try to resolve this into something intuitive. He accepted the instability. Because once observation becomes part of the system, you lose the privilege of standing outside it. You are no longer a spectator, you are a participant. And that means the deeper you look into space, the less you can separate what is there from what you are doing to see it. The disappearance of solid reality. You still want something solid, even now. After giving up empty space, after giving up a passive background, after accepting that observation interferes, you're still holding on to one last anchor. You believe that at the very bottom, reality must become definite, that if you look closely enough, carefully enough, you will eventually find something that simply is, a particle, a point, a final piece of certainty, but that expectation is the next thing to go. Because the deeper physics looks, the less reality behaves like something you can point to. Take a particle again, not the simplified version, the real one. You try to assign it a position, but you cannot do that without introducing uncertainty in its motion. You try to pin down its motion, but then its position becomes uncertain, not because your tools are flawed, because reality itself does not allow both to exist simultaneously in a fully defined way. So the particle begins to lose its sharpness. It is no longer a point, it becomes a spread, a range of possibilities, a distribution. Now your intuition reacts. You try to reinterpret this as ignorance. You think We just don't know enough yet. Maybe the particle does have a precise position. We just can't measure it properly. But that interpretation fails, because the mathematics doesn't describe hidden certainty. It describes fundamental indeterminacy, not we don't know, but there is nothing exact to know. So the particle stops being an object, it becomes a probability, a set of potential outcomes, a cloud of what could happen when you interact with it. And this is where the last piece of your classical picture breaks, because now you no longer have solid things moving through space. You have probabilities interacting with probabilities, fields fluctuating, outcomes emerging, nothing sharply defined until interaction forces a result. So what you thought was the most concrete part of reality, the particle, is no longer concrete at all. It is conditional, context dependent, and deeply tied to the same unstable structure you've been calling space, which means the distinction collapses even further. You cannot separate the particle from the field from space, from the behavior you observe. It's all one system, a system that refuses to give you fixed pieces. Feynman embraced this discomfort fully. He described particles not as objects traveling along a single path, but as something far stranger, taking every possible path at once, interfering with themselves, producing outcomes that only make sense statistically. Not because reality is messy, but because your expectation of clean, solid behavior was never valid. So now you are left without your final anchor. No empty space, no passive background, no neutral observation, no solid particles, only relationships, only probabilities, only structure without certainty. And at this point, the question quietly changes again. Not what exists, but what does it even mean to exist in a system like this? Space as an emergent illusion. You have been treating space as something fundamental, something that must exist first, before anything else can happen. A container, a framework, a necessary starting point. But nothing you've seen so far actually requires that to be true. In fact, everything you've seen begins to suggest the opposite, because if particles are not solid objects, if fields are not separate from space, if observation cannot be detached from the system, then what exactly is space? You've been assuming it is the thing that holds everything together, but what if it is the thing that emerges from everything else? This is where the idea becomes difficult, not because it is complex, but because it removes the last piece of familiarity. You are used to thinking, first space exists, then things exist inside it. But deeper physics starts to reverse that logic. It suggests that what you call space might not be a pre-existing stage at all. It might be a result, a consequence of relationships between more fundamental elements, not a place, a pattern. Think carefully about this shift. If space is fundamental, then distances are real in a basic sense. Points exist independently. Separation is built into reality, but if space is emergent, then distance is not a starting condition. It is something that appears when certain relationships take a specific form. Closeness and separation are not absolute. They are derived. That means the idea of where something is becomes less meaningful at the deepest level, because where depends on a structure that might not exist in the way you think. And this is not just philosophical. Some of the most serious attempts to understand reality, quantum gravity, space-time geometry, information-based physics, all begin to hint at the same possibility. That space is not the foundation. It is a byproduct, a kind of large-scale illusion that becomes stable enough for your brain to treat as real. But underneath that stability, the structure may be entirely different, not continuous, not smooth, not even spatial in the usual sense, just relationships, just connections. Just rules governing how things influence one another, and from that something that looks like space begins to appear. Feynman never claimed to fully resolve this, but his way of thinking pushed directly toward it, because once you abandon the idea of fixed paths, once you accept that particles explore all possibilities, once you describe reality in terms of interactions rather than objects, The need for a rigid spatial framework begins to fade. You don't start with space, you start with behavior. And space becomes a convenient description of that behavior at large scales. So now you are left in a very unfamiliar position. You are no longer asking what exists in space. You are asking whether space itself exists in the way you assumed. And if it doesn't, then everything you thought was grounded, location, distance, or direction, becomes something far less certain, not false, but not fundamental, just emergent. The disturbing consequence. Now pause. Look at what has quietly disappeared. First, emptiness stopped being empty, then the background stopped being passive, then observation stopped being neutral, then particles stopped being solid, and now space itself may not even be fundamental. At each step, you adjusted. You let go of one assumption, then another. But you may not have noticed what this process is doing as a whole. It is removing the idea that reality has a stable foundation, not replacing it with something more solid, removing it. Because every time you try to identify something that just exists on its own, physics turns it into something relational, something dependent, something that only makes sense in context. So you begin to lose the idea of independent pieces. No isolated particles, no independent space, no detached observer, only interactions, only relationships, only a system where everything is defined through everything else, and that leads to a deeply uncomfortable implication. Because your intuition depends on independence. You think of objects as existing on their own. You think of space as existing whether anything is in it or not. You think of yourself as observing from the outside. But none of those positions hold up under deeper inspection. There is no clear boundary where something simply is, without reference to something else. Everything is entangled in a broader structure, not just physically, conceptually. Even the properties you assign position, motion, energy are not standalone facts. They are outcomes of relationships. So now ask yourself, if nothing exists independently, if everything is defined through interaction, then what is reality made of? Not objects, not space, not even events in the traditional sense. It becomes something harder to picture. A network without a center, a system without a fixed base layer, a structure where the idea of fundamental building blocks starts to dissolve. And this is where the discomfort becomes unavoidable, because you are no longer misunderstanding details of reality. You are misunderstanding its structure. Your mind wants a hierarchy, a bottom level, a final answer, something that doesn't depend on anything else. But the deeper you go, the less that idea survives. Feynman didn't give you a replacement for that comfort, he showed you how to think without it. To accept that the universe might not have a clean foundation waiting to be discovered, only deeper layers of description, more precise rules, better approximations, but no final, solid ground. And that leaves you in a position your intuition resists, not confused, not ignorant, but fundamentally unsupported. The end of nothing. You began with something simple. Space is empty. Objects exist within it. And reality unfolds on a quiet, stable stage. That picture felt complete. It gave you distance. It gave you separation. It gave you something that didn't need to be questioned. But that picture is gone now, not replaced, removed, because what you called nothing has not survived scrutiny. It does not remain still, it does not remain passive, it does not even remain clearly defined. It fluctuates, it participates. It resists being described as absence at all. And once that happens, the idea of a true vacuum, of absolute emptiness, begins to collapse. Not because we found something hidden inside it, but because the concept itself no longer holds. There is no clear boundary where something ends and nothing begins. Only different levels of activity, different ways of describing the same underlying structure. So the question changes one last time. Not what is in space, not even what is space, but was there ever a meaningful version of nothing to begin with? Because if every attempt to remove structure still leaves behavior, if every attempt to strip reality down still leaves rules, if every version of emptiness still carries consequences, then nothing was never truly nothing. It was a placeholder, a simplification your mind used to make the universe feel manageable. Feynman didn't replace the simplification with a comforting alternative. He exposed it. He showed that when you look too deeply, when you stop protecting your intuition, reality does not resolve into something cleaner. It becomes less negotiable, less dependent on what feels reasonable, and more indifferent to what you expect. So you're left with something quieter than an answer, a shift. You no longer see space as a silent container. You no longer see emptiness as absence. You no longer assume there is a background holding everything together. Instead, you are left with a system where structure never fully disappears, where relationships never reduce to zero, where the idea of nothing dissolves the moment you try to define it. And that is the disturbing part. Not that space is full, but that emptiness itself may be an illusion your mind cannot stop trying to create, even now.